Hello class, so this is your first actual video lesson. If you take trig with me next year, this is how all of our lessons are set up. But since I'm gone and we're on a tight schedule, I'm going to go ahead and introduce this next topic to you. Unlike everything else we've been doing previously, there's not much computation here or steps that we need to learn, but it's more about familiarizing ourselves with parent functions. So you just wrote your word worth knowing, which was parent function. And a parent function is just the simplest function of a particular type. So you'll see today we'll learn about 4 different types. There's linear, cubic, quadratic, and absolute value. And then there's actually more that we'll learn about tomorrow, on Monday. But these are the 4 most basic. And a parent function is the simplest version. But there are transformations, which are slight changes to a parent function that create a new graph. So you'll see some examples of those here later in the lesson. So if you go ahead and just fold your foldable, it folds in kind of like a book so that you have 4 flaps. And we're going to start with linear. In Algebra 1, you worked a lot with straight lines. You worked with linear equations. So that's what we're going to be working with first. So if you open up, you'll see that we have a graph and an equation in function notation. So the linear equation looks like this, f of x equals x. So if we created an xy chart, and remember, for an XY table, we try to use at least 5 values, and I like to use -2 through +2. That usually covers several points. And what we're going to do now is just plug in our x value and get our y values. So whenever we plug in -2 into this function, well, we just get -2. We plug in -1, we just get -1. We plug in 0, we get 0, and so on and so forth. So this function, the x value of a coordinate is the same as the y value. And so it forms this line, -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. And so if we draw a line, I want mine to be really straight. You will see that this is actually that line that we were reflecting about with our inverse functions. Okay, this is the most basic linear line. It's that y equals x line, or in our new notation, f of x equals x line. And that's it. So the way that we're going to remember what linear means is just it's a straight line. I'm writing that in highlighter because I want to remember it. And I want it to be bold and stick out to me. So this is the equation for a linear graph. This is what the graph looks like. And these are the words that describe it. So we've actually got 4 things we need to remember. Linear is a straight line. It looks like this. And this is the function for the parent graph, f of x equals x. Now let's move on to quadratic. So that's right over on the other side. And you can right away see the equation is f of x equals x squared. We're going to also create a table of values. And our x values are going to be the same. We're going to do 5 x values, -2, all the way through +2. Now that we've got our x values set up, we want to plug these into our function and get our y values. So when we plug in -2, it's going to be -2 squared. Remember, a negative times a negative is a positive, so this is actually going to equal +4. When we square -1, we get +1. When we square 0, we just get 0. 1 times itself is 1, and 2 squared is 4. So something interesting happens. I think this has a special word in English. It's like called a palindrome or something. Notice that it repeats and goes backwards from 0. So it's 4, 1, 0, 1, 4. And you'll see what that looks like in just a moment when we graph it. So -2, +4. Then we've got -1, +1. 0, 0. 1, 1. And 2, 4. Now the key to drawing these graphs is to create a smooth line through the parabola. And that's what it'll look like. So this isn't a point. This is like a smooth curve. And the word that we're going to use to describe it, I just used. It's called a parabola. And you may or may not have heard of this before. But that's what we're going to refer to it as. So here's the 4 pieces of information that you need to remember. A quadratic parent function is called a parabola, and it has a shape like this, where either both pieces go up, or you can have a frowning face parabola where both sides go down. And then the equation is f of x equals x squared. So that's how you know it's quadratic. So we're already halfway through. Now we need to go to the lower half, and we have 2 more types of functions. Let's look at cubic first, and the name is exactly what's implied. It's going to be f of x equals x cubed. We're going to create a table of values, just like we did in the other examples. We're going to choose the same x values, -2, -1, 0, 1, and 2. And now we're going to plug in those x values to find the y values that correspond. So when you cube -2, I'm going to do a little thought bubble up here. That means -2 times -2 times -2. So that's the same as +4 times -2, which is the same as -8. So when you cube something and it's negative, it's going to stay negative. So here our y values -8. When you cube -1, -1 times -1 times -1, it's going to be -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is +8. So now we have our coordinates that we're going to graph. So let's graph -2, -8. Be careful when you're graphing these. Make sure you graph it properly. Then -1, -1. 0, 0. 1, 1. And 2, 8. So it looks kind of weird right now because you've never seen this before, but if we draw a smooth curve through here, this is what a cubic function looks like. So the word that I use to describe it is squiggle. Okay, it's not very mathematical, but it gets the point across. It's a squiggle. So that's what we're going to call it, a squiggle. And I don't even know how to spell squiggle, but that's how I spell it. So again, we have 4 different things we need to remember about cubic functions. They're called cubic. The equation is f of x equals x cubed. It's a squiggle shape when you graph it. And so unlike the parabola where we had both arrows facing up or down, we now have a graph where one side's facing down and one side's facing up. I call this dance moves, which we'll talk more about later. So that's what that graph looks like. Now we're on to our last one called absolute value. And you've probably seen some graphs somewhere that looks like this before. But let's go ahead and create our table of values before we talk about the graph. So xy we're going to use the same 5 values, -1, -2, 0, 1, and 2. And now we're going to plug it in. Now, if you don't remember, absolute value bars basically mean make positive. Okay, absolute value bars make whatever's inside them into a positive. So if we plug in -2, then our output's going to be a +2. If we put in -1, we should get a +1. If we put in a 0, well, there's no sign on 0, so it just remains 0. And the bottom two are easy because there's no sign on them, they just stay the same. And that's it. So when we go to plot these points, something interesting happens. We have -2, 2, -1, 1, 0, 0, +1, 1, and +2, 2. So it looks like a little V shape, and that's actually the way the graph is supposed to be. So unlike the parabola, this is going to be pointy on the end. So that's how absolute value is easy, because it's a V shape. So that's what I'm going to write about that. That's the descriptive way to think about it. V shape. So the 4 things you need to remember. This is called the absolute value parent function. Its function is f of x equals the absolute value of x. The graph is a V, and that's how we describe it, V-shaped. So if we take a step back and we look at all 4 of these, we can tell that they're all very unique. So our goal here today is to be able to differentiate between them and use the different words and the different equations to describe these parent functions. So what I want you to do is go ahead and grab your ISN. We're going to take a moment to glue these in, so grab your glue stick. Remember to glue things in, we're just going to go around the edges and then crisscross in the middle, and that'll be more than enough to make it stick. Press down hard. Also, if you haven't already done this, you need to make sure to label your page numbers, which are 21 and 22, and the date is 9/5. And this lesson is Skill 6, Graph, Parent, Functions, Part 1. So there you have it. That's what your left side should look like. Now I want you to grab your ruler and a highlighter, and we are going to divide up the right-hand side into 4 equal segments. So we're going to do a little sorting activity. This is what this is for. Alright, so you may not have known what this is for. We're going to do a sorting activity. So go ahead and just divide it into 4 equal pieces and label each piece. So the top one I'm going to call linear. This one I'm going to call quadratic, cubic, and absolute value. Now, I went through that pretty quickly, so you might need to ask the sub to pause it before we move on. So now that you've got all 4 quadrants set up, I want you to take this and just go ahead and cut it into 12 different pieces. The most efficient way to do that is probably to cut strips and then stack up the strips and cut those like I'm doing. Okay, so you should have 12 graphs. And what we're going to do is in your groups, you're just going to sort them based on what they look like. And in your group, I want you to all just grab one, and everyone will try to find their piece that matches. And they'll say, okay, which type do we think this is? Linear, quadratic, cubic, absolute value. The more you say the words, the more ingrained they're going to be in your head. So don't just start sorting them silently by yourselves. I want to hear discussion. I want you guys to be using the words. And then once you figure out which one you think it is, I want you to look at the equation. Like this one is a cubic. We know that because it's a squiggle shape. And then I want you to even say, okay, so a cubic function is f of x equals x cubed. And then move on. So I want you to go through and touch base with all four aspects of it. The name, cubic, what the graph looks like, the descriptive word, and the equation. Now notice all of these are not exactly like the ones in your foldable. That's because the ones in your foldable are the parent function. The ones in your activity are transformations or baby functions, as I like to call them. So they are slightly different from the parent function through some transformation. So go ahead and with the rest of your group, go through all of those. I want your sub to pause this while you guys are finishing up and give you about 5 to 10 minutes. Once you guys have sorted them, then unpause the video because I'm going to go through each one and lay them up here just like I would in class. So pause it now. Okay, now that you guys are all done as a class, the next one I'm going to grab is right here. This is a straight line. That means that it's a linear function, which means its equation is f of x equals x. The next one I have, be careful about this. Remember, if you hold it sideways, that's no longer a function. So it needs to look like this. It's a parabola, so that means it's quadratic, and its equation is f of x equals x squared. Our next graph, again, make sure you have it turned properly. This would not pass the vertical line test, so we need to make sure it's upright. And this is a V shape, so it's absolute value. And its equation is f of x equals the absolute value of x. Now I'm just going to go ahead and go through the rest of them. Grab this one. It's another parabola shape, so it's going to go under quadratic. This one is another V shape, so it's going to be another absolute value. Here we have a stretched out squiggle, but it's still going to be cubic. Here we have a parabola shape, so it's going to go under quadratic. Here I have another V shape, so it's going to go under absolute value. Now keep in mind, some of these parabolas and absolute values you may have turned upside down, but as long as it passes the vertical line test, it's still a quadratic, whether it's a frowny or a smiley. Here my little squiggle's a little bit cut off, but that's a cubic. And then my last two are straight lines. And even if it's a vertical or, well, that's not a function. If it's a horizontal line, that's still a linear function. So now that you have them all correct, go ahead and lay them down and glue them. And then once you're done with that, I want you guys to work on your homework. You can work in groups, but you may not change seats. And have a great weekend. I'll see you guys on Monday.